Good afternoon, and welcome back to Quantitative Reasoning Online, Lesson 11C. Okay, should have just finished up Lesson 11B, and now let's go into Lesson 11C. Let's see, what is 11C? Well, it says, can you hear me now? Last time I heard that was during a Sprint commercial, a long time ago. And of course, 4 questions. So with no further waiting and no further ado, let's get into Can You Hear Me Now? And let's see, what are the goals of this one? Evaluate an algebraic expression by hand and by spreadsheet. Observe the changes in the output value of a function as the values of the parameters changes. Okay. So how does y change with x or whatever else? That should be doable. Now in the next class you will extend your understanding of logistic relationships by exploring a growth formula and the effects of change in the parameters on the output value and the shape of the graph. The tutorial for preview of Lesson 11, Part C, Can You Hear Me Now, begins here. Alright, let's see what we got here. A parameter, here's a definition. A parameter is a quantity that influences the output of an equation. So a parameter influences output of the equation. Parameters are usually defined as a constant, while the value of the variable in the equation can change. For example, the relationship between the value of a British pound and US dollars can be modeled by the equation B, British pounds, equals Ka, where B and A are variables represented by the British pounds and the US America dollars respectively, and K is a constant that's defined by the current exchange rate. So pounds equals K times dollars. And think about it. What this gives us, US dollars is the input variable, output pounds, and of course more dollars you have, the more pounds you have. And this slope is basically the K. View the prompt. On one day, the exchange rate model might be B equals 0.60A, with the parameter K equal 0.6. Under these conditions, American tourists exchanging 5 US dollars will receive how many pounds? Okay, again, B equals 0.60A. That's pounds. Here's dollars. So pounds should be 0.60. I want to exchange $5 for it. And I should get in return 3 pounds. Oh, goes in front. 3 pounds. Why is that a pound? I have no idea. So basically, it's this exchange rate, this relationship is a linear relationship. Using those same conditions, an English tour exchanging 5 pounds will get how many US dollars? Again, remember B was 0.60A. This is pounds, dollars, and I have 5 pounds, 0.60A with algebra. So that should give us 5 divided by 0.6. I'm going to need a calculator for that one. So 5 divided by 0.6. So it looks like I should get $8.33 in exchange. $8.33. Yep. Here was a setup. 5 pounds is 0.60 American dollars. Okay, next day, depending on the world market, the exchange rate might change, making K equal 0.61. And the model becomes the British pound equals 0.61 American, or 0.61 American gives you pounds. In that case, how much would the American tourist with US 5 receive in British pounds? Let's see, so pounds would be 0.615, or I should get 305 pounds. Yeah, 3.05. Check answers. Yep. So you get an extra 5 shillings. Was that 5 pence? A shilling is a pound. You just know that stuff. Okay, in the next lesson, you will work with parameters of the equation shown below. Okay. Ooh, kind of looks like a logistic equation there. Equation, another form. Logistic equation is often used as a model for population growth. This form of equation has an input variable x, an output variable y, and 3 parameters, a, b, and c. Values for a, b, and c determine the relationship between the time and the population. So time is x, and y is population. Shape of the graph can be explained by how the variables and parameters interact. The following exercise will help you understand how the value of the carrying capacity, which is A, and the location of the inflection point of a logistic curve determines the shape of that curve. Typically, 1/2 A. Ooh, doggy, now we got spreadsheets. Click the link below to open spreadsheet 11C preview assignment. Let's see. So here is our parameters, A, B, and C. Oops. And we're looking at different parts of it. Here's a full equation, xc to the b, xc, xc to the b, 1 plus xc to the b, then a over 1 plus xc to the b. Oh, how nice. Notice that A, B, and C. Let's investigate how the values of the fraction x over c changes as x changes and c stays constant. Enter the formula shown for cell E6 to populate x over c. Okay. Enter form. So we want to enter D6 over $E $2. Now D6 is column D, row 6, so we're talking about this guy. And E2 is that guy. So, yeah, X over C. Okay, so equals, highlight the cell up here for the formula, equals X divided by C. Okay. And we have to add the dollar signs, which are essentially anchors. So essentially anchors, so that as I move things around, so let's go down, we'll go back later. Notice D2. Notice how that C is always highlighted. Still got C. Still doing C. I go this way. Nope. Still got C. I go down. These guys move, but it always stays the C. Remember, I go up or down, left or right. Okay. So these dollar signs act as anchors. Got ahead of myself. Okay, so change X. Let's see. Use the dollar signs. Change. Let investigate how the value of the fraction X over C changes as X changes, C stays constant. That's what dollar signs are for. In the formula shown for C cell E6 to populate the column, click and drag from E6 to E26. All right. So E6 to E26. All right. Note that using D6 in the formula means that the formula would change it. Yeah, using the dollar symbols, and because it was the value of E26. The value of E26 is E26 is 5. Five. And I think that's what we got. 5 was 2.5. 5 was 2.5. All right. Next page. Okay, so the behavior as X increases, what's it doing? As C is constant, as X gets bigger, looks like X over C is also getting bigger. Nope, it's just A. As X gets larger, X over C also gets larger. Now complete the column for X over C to the B. Okay, so let's see. We want X over C, which is here. And we raise it all to the B power, which is over there. And then we don't want that to move around, so we will then anchor those guys. Okay, so I'm going to put it in. Equals what? X over C. And then we'll raise it, little up arrow, to to the b power. And again, I'm going to move around. I don't want this guy shifting on me, so I'll anchor it. Divide by 0. Ooh, let's see. Appropriate value in cell 6 using dollar symbol, blah, blah. Note C, cell F6 will give you an error message. Don't worry about that right now. You will investigate the problem in a minute. So what are we supposed to do here? Oh. Drag to the F26. And check is 0.0016. 0.0016. 2.0625. Or 200. Oops. 400.0625. 2 was 1. Yep, we matched it. View the prompt. What is the value of F26? F26, 0.0016. No, that's what the that's what the okay. So which of the following best describes the behavior? Well, let's see. So as x gets bigger, it looks like xc to the b gets smaller. As x increases, the value of xc over b decreases. And that is because of the negative exponent. Basically, x to a minus power is really 1 over x to the power, which is why they reciprocated from here. So if x over c increases as x increases, therefore c over x, the reciprocal, is going to get smaller as x increases. Okay, if we were able to extend the table to include even larger values of x, what number would the value in the column F approach? Well, let's see, it's getting smaller and smaller. It's staying positive. It's going to work. It works on this one. So I keep getting bigger here. This gets larger. This will get smaller. And eventually, basically approach 0. Never quite, but it will approach 0. Very close to 0. Zero. Yep, and we'll get close to 0. Explanation: top of the table, the values are dropping rapidly by about 20 or so, starting in the thousands, and it will eventually go to 0. You may recall the meaning of a negative exponent from previous courses. Let's refresh by looking at a place value chart. Let's write each of the decimal values as a fraction of 1/10, okay, 1/10 basically tells me it's 1/10. In fact, all these guys are that is that. 1 is 10, 1/10. 2, 1/100. 3 is 1,000, so this would be 1/1,000. Of course, 1/10,000. Fourth, 10,000, 1/10,000. 10 squared is 100. 10 to the minus 2, 1/100. Fraction form of 0.01. Again, 1/100th. So 1/100. Verbally, 1/100th. So 1 divided by 100. .001. Well, that is 1/1000th, or 1/1000. In your notebook, write your observations about the relationship between 10 to the first, 10 to the minus 1, as well as other powers of 10. How does this relationship relate to the work you did with x over c and xc to the b in the spreadsheet? Basically, 10 to the 1 equals 10. So 10 to the minus 1 would be 1/10. 10 squared is 100. So 10 to the minus 2 would be 1/100. 10 cubed is 1,000. So 10 to the minus 3 is 1/1,000, etc. X over c was 10. X over c, the b would be 10 to the b. Of course, if it was minus b, it would be x over c to the minus b, or c over x to the b is reciprocal. Oh, need something. Yeah, that too. Well, let's see. We gotta go find a website. So read at least the first 5 paragraphs of Mark Satcher. Oh, here we go. Of all this. So let's copy it, minus the period. Copy. And let's pull it up. Okay, I was having some trouble getting that website up, so I had to go searching elsewhere. So, if you want to do the pull-up on your own, you may have luck with what they had in the book. Otherwise, just use this guy. Same. It's what we want. Study market saturation slows mobile phone growth, which is the same as here. Just different way of doing it, different place. So they said, what did they say to do? They say to read the first 5 paragraphs, and what we're trying to find is the number of mobile phone was projected to be how many billion by the end of 2013. Wrong one. So let's see, 1, 2, 3, 4. How many billion? Let's see, looks like 2.4 billion here. Now let's see, phone owners, Wisconsin, WI said group 1 billion to projection of 6.8 billion by end of 2013. What's being asked for? Again, the number of mobile phone subscription was projected to be how many billion in 2013? Projected. I'm going to say 6.8 billion by the end of 2013. So I wrote it correctly. Woohoo! All right. Like I say, you want to go look at this on your own. Actually, what I did to find this, then I just did a search of the entire what was given to us, and there it is right there, right on top. Using Google, and here we go. So it's an interesting read, nothing else. Our answer was 6.8, and yes, we found in the second paragraph. Oh, read the third paragraph carefully. The third paragraph, 1, 2, 3. Third paragraph, the annual rate of growth is beginning to slow. So it's on the curve down. Still growing. But it looks like we're getting this part of the curve. However, as markets become increasingly saturated, additional annual additions to mobile subscription peaked in 2010 at 680 million. Subscription rate began to dip in 2011, and estimate 424 will be added in 2013, some 215 million fewer than 2010. Okay, so we got to keep some of those numbers in mind. Read the third paragraph. Which of the following statement accurately reflects the information? The number of phone subscriptions declined from 2010 to 2013. The number of new subscriptions in 2013 was fewer than the number of new subscriptions in 2010. Okay, so the number of subscriptions declined, or just new subscriptions are declining? The new subscriptions are declining. There you go. Usually give a little pop down. Ah, interesting. Oh, Surveyor. It's by spreadsheet. And observe change in output value of function as the values of the parameters changes. Somewhat confident. So we did evaluate algebraic expression by hand and by spreadsheet, most by spreadsheet. Observe changes in the output value of the function as the value of the parameter changed. Basically, as x goes up, x over c goes up. As x goes up, c over x goes down. But basically what they're saying there. And new topic. So with that, we completed the tutorial. That's a little more convoluted than the other ones, but with the website. Try on your own, and I'll see you shortly for questions 1 through 4.